Now that we have some familiarity with electron geometry and molecular geometry, I want to go ahead and redraw all of these compounds again. One, because that's a good practice to see it one more time. And secondly, we need to assign their actual geometries based on the drawings. Again, we're drawing them in 2 dimensions, but you need to understand that they're actually, of course, in 3 dimensions. So to start off, I'm going to go a little quicker than I normally do. We have HF, which would look, which would look a lot like this. So HF, of course, I'm going to go ahead and use Mg as my molecular geometry. And you could tell it is basically looks like this. So we're going to call that linear because, again, we only have 2 atoms. Therefore, it really can't be anything other than linear if you think about it. And the electron geometry, which I'm just going to go ahead and put for shorthand, which is also going to be linear. The reason why these are going to be the same is because we do not have a center atom that can be influenced by unbonded pairs. Yes, the fluorine has extra electrons here, here, and here, but because there is no center, it's not really going to have any bearing whatsoever on the shape of 2 atoms bonded together. No matter how you think about it, they're going to be the shortest distance between them, which is a line, or linear in this case. The next one we have is water. Oxygen in the middle. We have a hydrogen here. We have a hydrogen there. And then we have 2 pairs of unbonded electrons. Notice I drew it in this particular configuration, and that is because this is the correct way to draw it. So the molecular geometry would be, not surprisingly, bent. Okay. And the electron geometry, because again, you kind of have to think of these unbonded pairs as electron clouds where the pairs of electrons are going to spend their time. We're going to call that tetrahedral. Now, again, if you think about it this way, this is the hydrogen, this is the oxygen, this is the hydrogen, and then if I rotate it, these are the 2 pairs of unbonded electrons. Again, hydrogen, oxygen, hydrogen, that's the water down here on the bottom of your screen. And then we have up here the unbonded pairs of electrons. So I know on the page it looks flat, but it would actually be a 3-dimensional tetrahedral shape for the electron geometry because electron geometry takes into account the unbonded pairs of electrons on the center atom only. Again, if I have extra electrons on my fluorine, it doesn't make any difference whatsoever because, again, there is no center atom. That does not play any effect whatsoever. The next compound we have is methane or carbon tetrahydride. So carbon, hydrogen, 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 bond, 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 bond. Okay, there we go. Again, not surprisingly, the molecular geometry is tetrahedral. Okay, and the electron geometry, again, because there is no extra electrons on this carbon here, there is nothing that is unbonded, then these 2 are going to be the same. There's going to be no difference. So this is still tetrahedral for molecular and the electron geometry. Okay? The next one we're going to do is going to be ammonia, NH3. So I have a nitrogen, a nitrogen in the middle. I have a hydrogen, 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 1, 1, 1, unbonded pairs because, again, nitrogen gets 5. So the reason why I drew it like this is because this is going to be the real configuration. So what molecular geometry this is going to be pyramidal. Okay. The reason, again, is this unbonded pair of electrons is going to repel and push those hydrogens down. So it's going to be shaped much like this. This is the nitrogen, the 3 hydrogens, the unbonded pair of electrons up here, pushing the hydrogens down. What we get is somewhat of a pyramidal shape. Okay, then in that case, we also need to think for our electron geometry of this as an electron cloud. So now we have an H, an H, an H, and an electron cloud, which makes it tetrahedral. So we'd have a nitrogen here, we'd have a hydrogen, 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 unbonded pair of electrons. So that would be tetrahedral. And 4 things off the nucleus or off the center atom, make it tetrahedral. And what, again, when we do electron geometry, you need to take into account the unbonded pairs of electrons. All right, the next one we have is CO2, carbon in the middle. We have a double bond to an O, double bond to an O. Okay, again, the molecular geometry is going to be linear. Okay, again, it looks just like this. This is carbon dioxide. We have a carbon in the middle, 2 red oxygens. So it is linear from red to black to red. And then again, there is no extra unbonded pairs of electrons. The carbon does not contain unbonded pairs of electrons. So its electron geometry will also be the same, linear. Again, the only time these are different is when we have unbonded pairs of electrons on the center atom. Okay. All right. The next one we have is N2. N2 is interesting. It has a triple bond like so and a pair of electrons on either side. Again, anytime we have 2 atoms, it's always going to be linear. And because again, even though they both have a pair of unbonded electrons, it doesn't make any difference because it's not a center atom. Therefore, my electron geometry is also going to be the same of linear. Okay, the next one we have is, I'm going to go ahead and do BF3. So BF3 again is an exception to the octet rule. Therefore, it cannot actually get its 8. Fluorine should have 7. Okay, there we are. Its molecular geometry would be trigonal planar. Okay, again, that means a flat triangle. The reason why it's flat and not bent is because, again, there is no unbonded pairs of electrons. If it was an unbonded pair of electrons, it would force the other fluorines down into a pyramidal shape if there was an unbonded pair of electrons. But because boron only has 3, excuse me, it does not contain any extra. Therefore, it is just trigonal planar. Again, to highlight what I'm talking about, if you look right here, these two look very similar. Nitrogen has an unbonded pair, which again will push down, making it pyramidal. Boron does not have an extra pair of electrons, so it's going to be nice and flat, 2-dimensional, trigonal planar. And again, that is the same for its electron geometry. Also trigonal planar. Again, they are going to be different only if there is an unbonded pair of electrons. Again, notice here, right? Or here, if there's unbonded pairs on the center atom, then they are different. The next one is we have HCl, oops, let me put a little more space there, HCl. Okay, again, 2 atoms mean automatically going to be linear for the molecular geometry. For the electron geometry, again, same thing. Not surprisingly, same as this, same as that. That's not a surprise. The next one, SiO2, SiO2. Again, it shouldn't be surprising that these two look basically the same because carbon and silicon are on the same group. Therefore, they have the same number of dots. Therefore, their compounds are going to be basically identical. Its molecular geometry, of course, because again, we have double bonds on both sides, is linear. Its electron geometry, because there are no unbonded pairs of electrons on that silicon, then it is also going to be linear in electron geometry. So again, there's an example. So just as a review, the shape of the atoms is determined by the center atom. If there's only 2, it's linear. If there's more than 2 off a center atom, then it's going to change the shape. You look at the shape based on the atoms, and then you have to take into account, again, its unbonded pairs of electrons, because these are really important, only if it is on the center atom. Again, silicon, no extra electrons, carbon, no extra electrons, boron, no extra electrons. Therefore, these will be the same, right? But if we have unbonded electrons, then of course, I'm going to use pink, they are going to be different. Okay? So that's a little review of electron geometry and molecular geometry. Molecular geometry, you take into account the atoms. Electron geometry, you take into account the cloud or the space filled by the extra unbonded pairs of electrons.